This is the introduction for simulations in SolidWorks for beginners. I'm gonna walk you over the steps you need to take in order to get started with simulations. Choosing the type of fixtures, the type of force and pressure and mesh will be something different. Those will be the details. Maybe for another video, maybe I leave it up to you. I'm just gonna show you what you need to press in what order to get started and tell you about the logic, because there is some logic to it. Let's get started. Hi, I'm Aryan. If you're new to my channel, I help engineers and creative minds to bring their ideas into reality through learning SolidWorks with a very new and effective method. So if you're here to learn SolidWorks, if you're here as a student or as an entrepreneur or as a hobbyist, you are in the right place. Let's get started. In the previous video, I taught you about 3D sketching, and I used the same base sketch that I had to create this component. It's a simple sweep, and I'm gonna actually ignore this fillet over here. This is what we have, and we want to apply some simulations to it, or we want to simulate it in a better way. First of all, if you don't see simulations here, it's because you haven't applied it to your default. So when you open your SolidWorks, the simulations loads on default. It's not happening, that's fine. You go to tools, you go to add-ins, and you find simulations here. I have already done this 2 minutes ago, so it's already checked. If it's not, just check it over here. And if you work with simulations quite often, you could just check the startup. So every time you open your SolidWorks, it loads simulations and it adds 5 seconds to your loading time. I'm not gonna do this, and I'm gonna click OK. Now that I have done so, I can right click on one of these tabs, doesn't matter which one. I can activate simulations. Just similarly, I wanna let go with analysis preparation. I don't need it. So when I go to simulations, I see one active button and that's it. Before I click on new study, I'm gonna click on this arrow and show you that there is a simulation advisor as well. If you wanna read it, you can do so, but I'm gonna quickly go to new study. This is a very important topic over here because there are different type of simulations that you can perform in SolidWorks, and depending on what simulations package license you have, because just like the SolidWorks you buy that has standard, professional and premium package, the simulation package on its own has also 3 standard, premium and professional package. And I happen to have the standard package for simulations plus the premium package for my SolidWorks. That's why I don't have some of these options active here. And the only way I can simulate my components are through static simulations. For example, if you're going to do simulations on an elastic material like type of polymers or nitinol, you need to work with the non-linear simulation, which is not active in my license, and I think you need to have the premium package for that. I don't want to go very deep on that topic. Let's assume you know that and you want to go on with the static, which is a linear type of simulation. So we just click OK. Immediately, you will create one tab over here on the bottom, which is static 1, but since I already had one, this becomes static 2. And you see there is some sort of a new interface to it. This is our property manager on top of the default property manager that we had here. Sorry, feature manager. You will see 6 features over here. The first one is the part itself. Then we have connections, fixtures, loads, mesh, and results. We need to assign some boundary conditions and we need to assign some features before we can start the simulation. So let's walk through all of them. Step number 1, first thing first, you need to assign a material to your component. Without assigning a material, or more importantly, the mechanical properties of a material to your geometry, the simulation doesn't make sense, because SolidWorks cannot take a guess for you and say this is a metal or wood or water or whatever. So you need to define that, and this is how you do it. You right click here, you can apply or edit the material that you have already assigned, or in case you have multiple components together like in an assembly, you can apply material to all of them by choosing this option. So let's just do this and assign plain carbon steel, which I already did. You see the name here. That's fine. Connections. I don't need to add any type of connections because this is a single component and it's not connected to any other component. I don't have any springs, I don't have any bolts or nuts or bearings or such, because these are the options you get, like pin, bolt, bearing, and so on and so forth. So I'm gonna skip that, go to fixtures. I cannot skip fixtures, it's mandatory. This is step number 2. Your component, as you see it here, is actually floating in SolidWorks. So if I assign even 1 Newton to this surface, it would just move to eternity because there is nothing stopping it. So you need to assign some sort of features, and there are quite a few different types. I don't want to go to all those details right now, but just I'll give you a quick glance. Right click on fixtures and select any of them, doesn't matter because it will take you to the next step. First of all, we have 2 tabs up here, type and split. We leave split for now and we stick to the default tab type. All right, so just like mate, almost like mate in assembly, we have the standard fixtures and we have the advanced fixtures. Let's go over the standard ones. We have 3 of them. Fixed geometry. As I said, fixture defines a vertex, edge, surface, or multiple surfaces or edges as a fixed anchored point. So that selection, if I, for example, select this surface will be fixed. For example, if this is connected to a wall, if it's welded to another component, you could simulate that. Say, okay, this surface is not moving. Now, let me zoom in. What do you see? What are these green symbols? If you look at it, these are green arrows, and there are in group of 3. We have in the X, Y, and Z direction. So when I see an arrow in the X direction, it means that selection, in this case, this surface cannot move in the X direction. So when I see a group of 3, it means this selection cannot move either in X, Y, or Z. It's fixed in all those 3 dimensions. All right. So I don't want to fix this surface, so I unclick it. Let's just move it. I'm going to select this and this. These 2 surfaces are completely nailed to the ground and they're not moving. I can click OK, but I told you this is only the fixed geometry. We have roller slider, and you always see the preview here. This is for moments that you want your components to slide over a surface, but it cannot get away with it. It has to be in contact with it at all times, however it can slide. If you want to assign a fixture like that, we have the hinge. As you can see, it's for hinges. So your components can rotate within each other concentrically, but they cannot move away. These 3 types are the standard fixtures that you have. Moving on quickly to the advanced mate, which gives you much more option, we have symmetry and some other. For example, this is for another video, but just for example, we have on cylindrical surface that allows your component to expand, rotate, or slide in a cylindrical surface. All right, just keep that in mind that there are much more complicated options in the advanced section of your fixture in the simulations. Good. Going back quickly to standard, choosing fix, selecting these 2 surfaces and clicking OK. As you can see, the arrows stay here and I have 1 fixture. Next, I'm gonna have to assign a load. I'm gonna select this surface here. As you can see, this is the direction of my force and this is the magnitude. Let's just set it to, I don't know, 10,000 newtons, which is about a ton, right? So the direction is wrong, or it's not wrong, it depends on me. I can just flip the direction if I want, reverse direction, or I can leave it like that. Let's just leave it like that and click OK. All right. Now at this point I can quickly jump to run this study and get my results. Before it happens, there is another step that SolidWorks takes care for you, and that is the meshing. You could either do that manually by right clicking on mesh and create mesh. You could assign fine mesh, which takes longer for your computer to calculate, or you could do a coarse mesh, which is faster to calculate, or you could just leave it in the middle. My computer can handle this, so I'm gonna leave it to fine. There is no point to it, just to show you that it can be changed. There are some parameters to it. We don't want to change that at this point. I'm just gonna click OK, leave it running until the component gets meshed. As you can see, I selected fine mesh, and they are very small segments that my component is now divided to. As a matter of fact, I can actually read how many segments it has created for me, but this is for another video as well. Let's just change the mesh quality quickly. As you can see, these segments are much larger. When you divide your component into larger segments, your results will be less accurate. If you divide it into smaller segments, your result will be more accurate, but it takes longer. I hope that makes sense. All right, leave it to fine, and then we have our fixture, check. We have our mesh, check, and we have assigned a type of force, check. So we have the 3 ingredients, and we run this study and we wait. All right, simulation pop-ups are quite often. You need to get used to them. Read what it says, it's important. Excessive displacements were calculated in this model. If your system is properly restrained, consider using the large displacement option to improve the accuracy of the calculations. Otherwise, continue with the current setting and review the causes of these displacements. Okay, yes. All right, another pop-up. Solver failed. Do you want to restart? Yes, I want to do that. If it fails like 1 or 2 times, that's fine, but if it fails 3 times, then it's gonna fail every time. There is something wrong, and you're gonna have to go back to your settings and adjust some of the stuff that you have defined and run it again. Let's give it a shot for a second time. Okay, so it is still running, and I think it can be done. I'm gonna give it another 5 seconds, and if it doesn't finish by then, I'm gonna stop it and create some coarse mesh to speed up the simulations. 1, 2, 3, 4, 5. All right, no need, cancel, done. I don't need to finish the simulations, that's fine. So go create a mesh. Let's actually reset it to the default, that's fine. And now run this study again. This time it should move much faster. While it's calculating this, let's just check what we have here. Reset iterations. You can set the maximum number of iterations for the simulator until it stops, which is this number on default. I don't want to change that. All right, okay. This is the result that we just got. As you can see, our component used to be here. This is where it was on default, approximately. And it has bent all the way towards here, and we get our phone misses scale here. The red describes 4.39 times 10 to the power of 10, which is a big number, but I don't see much red here, except that, yes, this is the point that we get red, and this is the point that we get blue. And as you can see, our yield strength is shown with this arrow over here, which is about here. Now, there's some stuff to it. It's not finished. I'm gonna change my fixture first of all. And this time, we're gonna speed up the video so you don't go and sit through all those simulations. I just changed the fixture and run the simulation one more time because I wanna move the stress point from this end to this end. It's almost finished. and done. Okay, as you can see, our component is now deformed. The red, which has the highest or represents the highest stress point, is here logically, and we have some stuff to cover. First of all, our result folder now holds 3 different results: one for stress, one for displacement, which I can activate by a double click, one for strain, as you can see, the units change here. By the way, let's go back to stress and talk about units. A simple double click on the active result will give you some settings to that. I can change the unit that I want from Newton over square meters to PSI, for example, or some other. And I can also change the amount of deformity. Is that a word? I can change how deformed my component should look. Currently, I have set it to true scale. If I set it to automatic, it might change. This is how SolidWorks decides to show you, but this is not the true scale. If you want to change it to true scale, double click, go to the definition tab and set it to true scale. This is important when it comes to displacement, because you want to see how much your component has actually been deformed. If you set it to an automatic and you do this, you might get a wrong feeling. Oh, it's not much. But the true scale tells you how much your component is actually deformed. And as you can see, it's in millimeters. The red component has been moved about 24-25 millimeters in this direction. Let's go back to stress and see what else we can do. All these 3 results give you some cool options if you right click on them. For example, you could delete them, copy them, print them, save them as. You could deactivate the deform result, go back to the default mode of your component, or you can activate it again. You could animate the motion that happens when you try to assign some force to it. See, this is exactly what's happening to your component. It's made of plain carbon steel, and we are assigning 1000 newtons in this direction to it. All these brown arrows now are the fixed part. That's why nothing happens to this area, and it stays completely blue. It's fine. Let's just click OK. Right click again. We could change some settings about our chart over here. This moves it to right and left and up and down. You could also drag it with your mouse. It's not that big of a deal, but you could change the number of decimals as you can see here. Also, we could go to chart options and change the color. It's also important because a lot of times you want to change the scale that you want to see here. The range varies from 9.06 times to the power of 2 all the way to 1.98 10 to the power of 10. So if you want to change that, you could uncheck the automatically define maximum value and define your own value as well as its color. So for example, if I remove 10 from here, this is the color chart that I get on my component. All the way up here, it becomes the red. But it doesn't make sense unless you have a desire or a specific reason to change the scale over here. Don't do that. I'm going to set it back to automatic so it goes back to the way it was, and click OK. Also, show max annotations if you want. It shows you this is it has the highest strain point and this has the lowest. In case this is something you want to see, you could check it over here. Feel free to explore these options. Nothing will harm your results unless you right click and click delete. So leave it at that, and we will cover more details in coming videos if you want me to, because this is just some sort of a warm-up to see if this is actually a topic you guys need. All right, I'm gonna finish the video at this point. I'm gonna wait for your questions in the comment section below. Don't forget to ask anything you want to know about this topic, and I'll see if I can make more video on this topic soon. One more thing, if you guys are struggling to learn SolidWorks essentials and simulation is too much of a topic for you, it's too heavy, it means you are at the beginner level. And for that, don't forget to check my website. The link is going to be in the description below. Go and watch my webinar. It will tell you the bad habits that every beginner is making for themselves, and I will show you how to solve that and replace those bad habits with good habits. It's very important to build good habits when you work with SolidWorks or any other software for that matter, because it defines how fast you work, how efficient your job is going to be done. So don't forget that. Go watch it right now. If you like this video, please leave a comment and tell me so, because if you don't, I assume I should move on to a different topic. If you like me to cover other aspects of simulation, which I'm not an expert in, but I still can teach you one thing or two, leave a comment, like this video, or actually do both, and let me know if this is something you want more of. Then I will do more videos on simulations. All right. Don't forget to subscribe to my channel. If you're new here, you have a lot to learn, and I'm here to help you with that. I'll see you in the next video.